Welcome back. We will continue with our max session. We were seeing about calculus. We will continue with the same topic. We will have a quick recall of what we saw. So far. So first thing we saw was function is nothing but relation between dependent and independent variables. Then that is, if I say y equal to f of x, y is the dependent variable, x is the independent variable. Second thing we saw was the condition for continuity. We saw two special cases and we analyzed and we established the fact that limit x tends to a minus f of x should be equal to limit x tends to a plus f of x, and this should be equal to f of a. If these conditions are satisfied, then we say f of x is continuous at x equal to a. This is a very important condition, and if this continuity condition is satisfied, then only I can define limit x tends to a, else I cannot define the limit x tends to a itself. Okay, this is what we saw, and from this we extended the idea to differentiation. What is the idea we got? We got this as infinitesimally small change in f of x with respect to x. This is what we have seen so far. Now let us continue this and see what this means in bigger sense. That is, we have defined differentiation of f of x as f dash of x, that is nothing but limit h tends to 0 f of x plus h minus f of x by h. Okay, this is what is the meaning of differentiation. Now let us see one classical example of differentiation. Well, this technique is very useful to understand and remember. Well, we have already known that if, let us prove one example, okay, for understanding. If f of x is equal to x power n, we have already studied that f dash of x, what it is? It is nothing but n x power n minus 1. So for the sake of understanding this formula, let us prove this result. So what is, if I go by standard definition, what is f dash of x? F dash of x is nothing but, let us write it again, limit h tends to 0, limit h tends to 0 f of x plus h minus f of x by h, which means this will become x plus h the whole power n minus x power n divided by h, limit h tends to 0. Limit h tends to 0. Now when we evaluate the limit, what we do, we directly substitute this value. Now if I substitute this value, what it will become? This will become, if I try to evaluate it, it will become x plus 0 the whole power n minus x power n by 0. This will become x power n minus x power n by 0. This is 0 divided by 0. This has no meaning. Please remember this. This is called 0 by 0 form and it has no meaning. So whenever we apply limit, we should be careful that we are not ending up having 0 by 0 form. Clear? So now the requirement, now we have to find a way out. The way to evaluate this limit. Why? I don't want to get 0 by 0 form. I don't want this answer. Okay? So let us evaluate that. So let us evaluate what is f dash of x. What is our f of x? F of x is x power n. So f dash of x was limit limit h tends to 0 f of x plus h minus f of x by h, which is nothing but x plus h the whole power n minus x power n by h, where limit h tends to 0. Now to prevent getting 0 by 0 form, I have to expand this in terms of binomial theorem. So what is binomial theorem? First let us understand that. These are small results which are very useful for GATE. This will definitely be helping in understanding many bigger concepts. So x plus h the whole power n, if I expand it by binomial theorem, this will be x power n plus nc1 x power n minus 1 h plus nc2 x power n minus 2 h square, plus it goes on till I get h power n. We know this result already, right? See, let us see how we know this. We have already seen, right? What is a plus b the whole square? It is nothing but a square plus 2ab plus b square, right? This is nothing but the expansion of this result. How? A plus b the whole square. Let us evaluate as per binomial theorem. We will understand. It is nothing but a square, because n is 2 here. So a square plus 2c1 a power 1, a power, actually it will be 2 minus 1 b plus, that's all, we end it. So we get b square, correct? So this is nothing but a square plus 2ab plus b square, which is what we have been knowing it, right? So like this we can, by the use of binomial theorem, we can find it for any power of n. Let me correct myself, any integer power of n, we can evaluate this expression. Therefore let us go back and substitute. Say, let me call this 1, let me call this 2, substitute 2 in 1. What we get? We get f dash of x is equal to limit h tends to 0, x power n plus nc1 x power n minus 1 h power 1 plus nc2 x power n minus 2 h square, and this goes on till h power n. Now I have written only x plus h power n. I have to write this x power n also, right? So minus x power n the whole divided by h. So this x power n and this x power n gets cancelled. The remaining terms, I notice that every term has h. All the existing terms have at least one h that can be grouped and brought outside. Why I am trying to group that h and bring outside? Because that h is the culprit which is taking the value 0. So that is the culprit. So somehow I have to, if I remove this, I can evaluate the answer. Correct? So if I remove all the h, if I remove one h from the numerator, I will get nc1 x power n minus 1 plus nc2, because I have removed one h, I will get x power n minus 2 h power 1 I will get, because I have removed one. Similarly, all the other terms I will get plus h power n minus 1 I will get divided by h. Now I want you to understand one concept here. I can cancel this h. I can cancel this h with this h because I have not substituted the limit. I have not substituted the limit. So I can cancel this h with this h. I can cancel this h and I can cancel this h because I have not substituted the limit. If I substitute the limit, what will happen? This will be 0 and this will be 0. This will become 0. This will become 0. 0 and 0 cannot be cancelled. Whereas h and h, they have not taken the value 0, so it can be cancelled. Now if I evaluate the result, what will I get? I will get limit h tends to 0 nc1 x power n minus 1 plus nc2 x power n minus 2 h power 1 plus so on till h power n minus 1. Now if I apply this limit, except this term, every term contains h. So every term will cumulatively become 0. And I will be left with the answer nc1 x power n minus 1, which is nothing but n x power n minus 1. This is how we get the derivative of x power n as n x power n minus 1. This is a very good point to understand. Like this, we can you can find the derivative of many functions using this. Okay. So having understood that, we have proved that f dash of x is equal to n x power n minus 1 if f of x is equal to x power n. This is what we have proved. Okay. Fine. Now let us go ahead and see some important concepts. First thing we will see is what do we mean by existence of a derivative? This is one important question we have to answer. What is the question I am asking? That is, if there exists some function some function f of x, then can I differentiate f of x anywhere? This is a very important question. Both these are same. I have what the second one I am just writing in a better way to understand what is the question. So let us understand this. So I state the answer as a theorem, that is, you can take it as say result 1, for example, just I am naming it. All differentiable functions are continuous but not all continuous functions are differentiable. This is very important to understand. Please remember this point. So, why I lose differentiability? In case, what I mean by this first statement, all differentiable functions are continuous, but not all continuous functions are differentiable. That means I have some continuous functions which cannot be differentiated at some points. Okay, so let us take an example. Let me take f of x equal to mod x as an example. How this function will look? F of x equal to mod x will look like this. It will look like this. This is my x, this is 0, this is minus x. Correct? So f of x equal to mod x, how it will look? F of x equal to mod x means f of x equal to x for x greater than 0 equal to minus x for x less than 0. Correct? So it will look like this. It will look like this. This is function f of x equal to mod x. Please notice that at this point there is a sharp change. So when I differentiate, what will happen? When I differentiate, what will happen? Differentiation is nothing but slope, correct? So the slope here is minus 1, the slope here is plus 1. Slope. Because differentiation of a function will give you the slope at a point, correct? So if I differentiate, I will get like this. So this is plus 1, this is minus 1, this is f dash of x. Now what is this? Is the way graph of f dash of x. Meaning of f dash of x is what? F dash of x. What is f dash of x? F dash of x is a limit. What limit? H tends to 0, correct? X plus f of x plus h minus f of x by h. Correct? This is what. The moment I express this as a limit, for me to define f dash of x, f dash of x, f dash of x can be defined only when limit exists. And when limit will exist? When continuity is there. When continuity exists. And what is the existence for continuity? Value should converge. Now observe at 0, if I travel in this direction, I hit this point. If I travel in this direction, I hit this point. So f of x equal to mod x is not differentiable. Is not differentiable at x equal to 0. But observe f of x. Observe f of x. Here if I travel in this direction and if I travel in this direction, both the time I hit the same value. So f of x is continuous, whereas f dash of x is not continuous. So the derivative does not exist. Hence we prove our result 1. So what we proved? All differentiable functions are continuous. But vice versa, this is true, but this need not be true always. Please remember. So let us go back to the same example of f of x equal to mod x and let us analyze that. Our f of x equal to mod x was looking like this. This is f of x equal to mod x. So I was able to differentiate here. But at this point no derivative exists. Correct? So what is that we are not able to differentiate it at this point? It is because there is a, like I marked in the previous thing, there is a sharp change in f of x. So what is the conclusion? The conclusion is, wherever any function f of x undergoes a sharp change or sudden change, at that point derivative will not exist. See, for example, let us take sine wave for example. See here, everywhere there are smooth changes. That is, in other words, if I have to say, no sharp changes. Correct? So, everywhere f dash of x will exist. So, sorry, this is a very important concluding remark. So we saw that for f dash of x to exist, f of x should not have sharp changes. Okay, now let us see two important theorems. First thing we will see is Rolle's theorem. So this is a very important theorem. With respect to me, Rolle's theorem is more of a common sense. Let us see how it is. What Rolle's theorem states is, if f of x is a differentiable function in interval AB, then such that f of A is equal to f of B equal to 0, then there exists at least one C which is within AB. I can write like this, or I can write like A less than C less than B, such that f dash of C equal to 0. It is very easy to prove that. We can prove that. We will prove that by analysis. Proof we will do by analysis. We will not mathematically prove it. We will analyze and prove it logically. For that, let us understand each and every word the theorem says. F of x is a differentiable function in interval AB. The moment I say that it's a differentiable function, that means what? F of x is not having any sharp changes in AB. Correct? Because it is differentiable. That means, and also what is told? F of A equal to 0 and f of B is 0. Which means the function f of x will look something like this is my A, this is B. At both the places f of x is 0. So it is going to go like this and come back, or it is going to go like this and do something like this and come back, or it can be something like this. It can be anything. Let me take number this. It can be like 1, it can be like 2, or it can be like 3, or numerous possibilities will be there. But what is the important point? It is not having sharp changes in the interval. Correct? So throughout the point it is smooth change. So f of A is 0, f of B is 0 means the function is either completely 0 in this interval, or it has grown in any direction like this or like this, and it has made a U-turn and came to 0 at B again. Correct? So if it is making a U-turn, then it would have reached either a maximum value or a maximum value or a minimum value before it came back to 0. And what do we know? F of x, f dash of x at maxima and minima is 0. Correct? So there should be some C. So there should be some C which is either maxima or minima. Correct? It's a logical argument. Correct? So both at maxima and minima we have f dash of x equal to 0. Hence proved.